Hi, my project is the analysis of a portion of the 1994 census. Um, the data I will be using in my project is collected from the 1994 census, and it was released by two people named Ron Kohavi and Barry Becker. These two published an article about the possibility of creating a hybrid model that combines the decision tree approach and the naive Bayes classification approach. They created an algorithm called the MB tree, and it was compared between two models, one called the C4.5 and the naive Bayes. And their results were very good. It decreased error significantly, even though like the absolute difference wasn't too much, only by like 0.04%. Oh, and so personally, I was always fascinated with machine learning, and so I came upon their article that they made quite recently, and one of the things they said in the article was that Kohavi released the dataset when his article was published, and because I was struggling to find a project topic at the time, I decided to choose this as my project. So yeah. So I'll show you what the data looks like. I got it from a UCI machine learning repository website. Let's see. This is what it looks like. And if you see here, it says like data folder, and if you click that, there's like 5 little other links. So the ones I looked at were adult.data and adult.names. And if I click, say, adult.data, I get this huge chunk of words and numbers. But what's interesting that you see here is there's no header, so you don't know what any of those words mean or those numbers mean. So if I go back and I click on adult.names, that's kind of like the information, like where all of the data is stored. So there's all of these like things, how like donor was Ronnie Kohavi and Barry Becker, but towards the bottom, go down here, towards the bottom, you'll see they have age, work class, all of these titles, and what I gathered from that was like the other file that didn't have a header, these were supposed to be its headers. So part of my project was to put that data together, and it was a bit challenging for me because if you look at the HTML here and spec, and you go here, you click on pre, there's no other tags within this. It's all just a giant block of text. So it was a bit hard for me to, go through all of this, but at the end, I ended up, doing fine, I guess, hopefully. So I'll show you my code, but so getting the column names was one of the trickiest parts of my project. I had to literally find each word within that huge block of text, and I'll show you how I did that when I get to it. So, okay, let's go. So this is a page where I scraped the column names from the HTML of the website that I showed you. I had, pretty basic libraries. I use Beautiful Soup, which helped me a lot. This is a URL of that page. And yeah, so I printed it out, and this is everything. Usually, like, you get some tags in there, and like you could see the individual objects, but this was literally it. It was like one giant block of text, and all the way down here was the text that I needed. So what I did is I went and found like the actual characters where they start. I know that's not a very good idea, but I mean, it was short enough, so I went ahead and did it. So after that, like, I just kept, finding the names of the individual columns, and at the end, if I can show you, I created a columns array with all of the columns that I need. Now, if I go to my other page, this is, my actual page for the project. Can I scroll down? Okay, so I needed a ton of libraries. A lot of them were the same though. So I set my working directory, created a pandas data frame of that adult.json file that we all saw. And of course, like, there's no header, so everything's just mushed into one. So what I did is I got rid of this random column right here with the lang. So I went down here, I took it out, and then where it says para, I used the column names. So the columns where I found in the other file, and I split it and I made some floats. Yeah, so I got all of this, but I still had this para and like this giant block of text. So then I go down here, and so I dropped this para, and I also dropped this ID column, and it literally, it just had like random numbers. It wasn't gonna help me, so I dropped that. And I also, there were some question marks and like NA values in my data, so I dropped all of the rows that had them. Yes, and this is how my data looked after that. Beautiful. So now I just like print some basic stats, like how many records are there? There's 30,000. And so I should show you this. Basically, the point of my project is to take all of this information and decide the financial status of the person. So here you have a scale, and you have two values really. It's just less than or equal to 50,000 and greater than 50,000. So that was like how much they would get in a year. And so I included those stats down here. And if you can see, there's only a fourth of the values in my data where people are making greater than $50,000. So like, I guess I should be wary of that when creating my model. So then I come here and I plot some stuff. So this is age over capital gain. Capital gain is like how much more you get. And if you see here, this is age, so you have 20, 30, 40, all the way up to 90. And capital gain goes up from 0 to 100,000. You can see the outliers are clearly the ones up at 100,000. And I'll see if I can fix that later on. And then I did another scatter plot with the years of education that you had and the capital gain. And it's pretty expected, but like the years of education, the more you have, the more years of experience you have, the more your gains. I'm running out of time here, better hurry up. This is also hours per week by capital loss. so this is hours per week that you work with capital loss. As you can see here, there's this line right at 40 hours a week, which is pretty much the standard for how long people work. So these are my correlation coefficients, and they're pretty weak, but positive. So what I want to do is go on to like preparing and normalizing the data. So here's some visualizations, and I plotted the value, which is a scale either less than or equal to 50,000 or greater than 50,000, against either a capital gain or a capital loss. And if you see here, there's this huge lines that skew the data. So what I did is I tried to transform it using a logarithmic transformation, and it got better. If we go here, this is my transformation of the data. It made it much better. If we explore it, we can see, so there's still about like a 25% of people who are greater than 50,000. So this might affect our data. So now we go to data cleaning and shaping. And first I made dummy variables, and there were 103 of them. And then I went to a grid. So this is for all of the qualitative variables that I was able to do through all the cleaning. So there it is, running out of time, so I'm going a bit quickly. Now I have to split the data into training and testing. Now we look at models. First, I'm going to make a naive predictor. Oh, whoopsies. This is a naive predictor right here, just like random values, just to compare it with all of my other models that I'm going to make. And this is a function that I helped to create predictions with the testing data set. So there are two training data sets. One is the features, which are all of the qualitative variables, and one is the income, which is all of the quantitative variables. So we have two of each with training and testing. So like this is a function. So then what I do is I have 6 different kinds of models total. I model them 2 at a time, and that's because with this function that I made above, it's going to be easier for me to compare more than one. So here I did the logistic regression, Gaussian, naive Bayes, and KNN, and those are things like we learned in class. And so like go through this function, yada yada. And then this is the performance metrics. So the thing I want to focus on is the accuracy score on testing set and the F score on testing set. You see here, the dark red performs higher than anyone else, and like, slightly higher. And you can see that that's the logistic regression model. So you can see that, that's performed the best, even though it didn't do so well on the training subset, but on the testing subset, it really improved. Now, for the other 3 lesser known models, we have the ADA boost classifier, the decision tree classifier, and the SVC. So I go through this same as above. And if we look here, so we look at the bottom right, the accuracy score on testing set and the F score on testing set, the ADA boost classifier scores significantly higher than the others. So we're going to analyze that and make it a little more accurate. So I find all of the variables that are most helpful in predicting, and I train it, and this is the value that I get. So accuracy on testing, 85%. Accuracy on test, so this is the final model, is 83%, which is very good. All right, bye.